Welcome to the Joy of Architecture. Today we're diving deep into something that's, well, becoming absolutely essential for software and cloud architects. We're talking about aligning your systems, your decisions, with the AWS Well-Architected Framework's sustainability pillar. Our goal here is to give you a real shortcut, cut through some of the noise, and help you really grasp what's important. We'll look at practical tips, maybe some surprising facts, those crucial trade-offs, basically helping you build not just for today, but, for a greener cloud future. Okay, let's unpack this.
It really is a fundamental shift, isn't it? When we talk cloud sustainability, we're essentially defining it as, well, minimizing the environmental footprint of cloud computing itself. And this isn't a small thing. The whole IT sector, data centers especially, they consume roughly 1% of global electricity. And projections, they show that number could climb quite a bit if we don't actively intervene.
It sounds pretty significant, but it's not all doom and gloom, is it? Cloud migration itself offers some hope here.
Exactly. Moving workloads from, traditional on-prem setups to the cloud, that can slash carbon emissions by up to, I believe, 84%. But here's the catch, or rather the important part. It's a shared responsibility. Cloud providers like AWS, they're responsible for the cloud. The physical stuff, the data centers, getting renewable energy, that's on them. But you, the architect, the customer, you're responsible in the cloud. How you design your workloads, configure resources, your operational patterns, those choices directly impact the actual outcome. Make inefficient choices, and you could wipe out the provider's green efforts.
Right, so this really goes beyond just feeling good about doing the right thing. It sounds like a serious business imperative now.
Oh, absolutely. It's strategic. Think about it. Investors, customers, regulators, they're all scrutinizing ESG performance. That's environmental, social, and governance. Ignore sustainability. You could face compliance issues, maybe penalties, definitely reputational hits. But flip that coin, strong sustainability attracts investors, boosts your brand, gives you a competitive edge. It's smart business.
And that's precisely why AWS added the sustainability pillar to the well-architected framework.
That's right. It's basically an extension zeroing in on minimizing environmental impacts, the core ideas. Understand your impact, use resources efficiently, adopt new efficient tech, use managed services, and this is key, reduce downstream impacts. What's really interesting is how it elevates sustainability. It's not an afterthought. It's right there alongside cost, performance, reliability, security. You have to consider it in your trade-offs.
So as an architect, your role expands. You're not just a tech builder, you're becoming an environmental steward in a way. You're influencing the company's footprint.
Precisely. Your decisions directly shape cloud resource consumption. And that ties into Scope 3 emissions, those indirect emissions from services you buy, like cloud. Framing sustainability in terms of efficiency, cost savings, better brand, that helps get everyone on board. It's not just green, it's smart.
Okay, let's get practical. One of the first big decisions is where you put your stuff. Region selection, that makes a difference, right?
A massive difference. It's foundational. Different cloud regions have very different carbon intensities, that's CO2 per kilowatt hour, and different levels of carbon-free energy, or CFE. Choosing regions with higher CFE or just lower grid carbon intensity, that directly cuts the emissions from running your workloads. It's a big long-term lever for your Scope 2 emissions, the ones from purchased electricity.
So what are the practical steps here? What should architects actually do?
First off, prioritize regions powered by renewables for anything new, or when migrating. Look for regions near renewable projects or just on cleaner grids, but you have to balance that. Latency-sensitive apps, maybe you need a closer, less green region. That's a trade-off. But for stuff that's not time-critical, think batch jobs, analytics, you can use what's called carbon-aware scheduling. Run them in the cleanest regions available, even if they're far away, or run them when the grid in your current region is cleaner.
That's clever. And can organizations enforce this? Make sure teams are choosing wisely.
Yes, definitely. Set up organizational policies. Restrict deployments to a pre-approved list of low-carbon regions. You can use cloud governance tools for this. Google Cloud, for example, has resource location restriction policies you can set to low carbon. Keeps everyone aligned.
Are the big providers actually doing this? Any examples?
Oh, yeah. AWS says 22 of its regions were matched by 100% renewable energy as of 2023. They're aiming for net zero by 2040. Stockholm, for instance, has a really low PUE power usage effectiveness, like 1.0. Lower is better, means less energy wasted. Azure has a 100% renewable region in Sweden, aiming for 100% renewable energy overall by 2025 and carbon negative by 2030. Google Cloud. They're aiming for 247 carbon-free energy in every region by 2030. They even flag low CO2 regions like Finland and Montreal, both at 100% CFE.
What tools can help architects make these choices? It feels like you need data.
You do. The provider dashboards are key. AWS has its Customer Carbon Footprint Tool, CCFT. Azure has the Sustainability Calculator. Google Cloud has its Carbon Footprint Tool. These give you insights by region, by service. Plus, providers are publishing more data on grid intensity and CFE percentages. And don't forget those governance tools for enforcement.
Okay, sounds good, but I sense some friction. Choosing the greenest region must involve some tough trade-offs.
Absolutely. The big one is latency versus carbon. A super green region might be halfway around the world, killing performance for your users. Then there's cost versus carbon. Sometimes greener regions might have slightly higher service prices, and, not all services are available in every single region. Plus, regulations or data residency laws might just force your hand, green or not.
All right, so region selected. What about the architecture itself, the design patterns? How do they play into this?
This is where you can really cut down on wasted resources. Think about event-driven architectures E-Day. Using asynchronous communication, reacting to events. It means services only run when they need to. They scale independently. Less idle time, less energy waste. Serverless is inherently event-driven, which is why it's so efficient.
And using queues for asynchronous processing.
Another game changer. Instead of processing everything instantly, synchronously, you use queues like SQS, event hubs, Kafka. Components talk through queues. Consumers process messages at their own pace. This smooths out peaks, avoids keeping servers idling during quiet times. Huge efficiency gain.
What about the whole monolith versus microservices thing? Does one have an edge for sustainability?
It's nuanced, like always in architecture. Microservices can be better if only parts of your app get heavy load. You only scale those specific parts. But they add complexity. Containers, though, Docker, Kubernetes, they definitely help. You pack more applications onto fewer servers, better utilization, less energy overall, but you need to manage it efficiently.
Any quick examples of these patterns working?
Well, there are e-commerce examples using serverless to handle massive holiday spikes, resources scale up, then right back down. Cuts energy use dramatically compared to provisioning for peak all year. And think about Netflix. Even if sustainability wasn't the initial driver, their massive event-driven setup using Kafka lets them handle huge fluctuations efficiently. That inherently means less waste.
But microservices do add complexity, managing all those moving parts.
For sure. Tracing, debugging, deployment. It's harder than a well-structured modular monolith, and breaking up a legacy monolith, that's a big project, lots of risk. So it's not automatic. It depends on the execution.
Right. Let's zoom in on compute. Probably the biggest energy draw in the cloud, I guess. How do we optimize that?
You're spot on. Compute is a primary energy consumer. Over-provisioning is just rampant energy waste. Optimizing compute directly cuts your operational carbon footprint. And less demand means less need for new hardware down the line, reducing embodied carbon too.
Okay, key strategies for compute. Number one, right sizing. Constantly monitor your instances. Are they loafing around at 20% CPU? Downsize them. Use the monitoring tools. Number two, auto scaling. Use it dynamically. Horizontal pod autoscaling, HPA, in Kubernetes, adjust replica counts. Vertical pod autoscaling, VPA, adjust resource request per pod. Cluster autoscalers, like Carpenter, add or remove nodes. Match capacity to actual demand. No idle waste.
And serverless fits in here perfectly again.
Perfectly. Adopt serverless like Lambda or Cloud Functions where it makes sense. Resources only exist during execution, zero idle energy cost. Also, multi-tenancy. If you can serve multiple customers from shared infrastructure, you pool demand and maximize utilization. And for containers, think bin packing. Squeeze those workloads onto the minimum number of servers efficiently.
Are there specific instance types architects should look at?
Yes. Look for energy efficiency. AWS Graviton processors, the ARM-based ones, generally offer better performance per watt, lower energy consumption for the same work.
Are companies actually seeing benefits from this, like real numbers? Definitely. You see names like Adobe, SAP, Nubank moving to Graviton, reporting better performance, lower costs, and reduced emissions. SAP mentioned something like a 45% energy efficiency gain for HANA Cloud on Graviton. And the providers themselves are optimizing. Azure uses AI to fine-tune power usage, getting PUEs below 1.2. Google boasts massive efficiency gains in their data centers using AI and smart systems.
What are the go-to tools for architects here?
Your cloud monitoring tools are Essential CloudWatch, Azure Monitor, Google Cloud Monitoring tracks CPU, memory, etc. The auto-scaling tools, native AWS auto-scaling, Kubernetes HPA, VPA, Cluster Autoscaler, Carpenter.
Serverless platforms, obviously.
Yeah.
And managed services like RDS often run on optimized hardware behind the scenes.
But there must be trade-offs with compute optimization, too.
Always. Aggressive right-sizing or scaling. You might see performance hiccups if you're not careful. It adds operational complexity, needs monitoring, automation, expertise. And while cost and sustainability often align, sometimes migrating to, say, Graviton has an upfront cost. Or if you've bought lots of reserved instances, maybe there's less incentive to optimize right now, which FinOps teams need to manage. Plus, legacy apps might need significant changes to work well in serverless or on new instance types.
What metrics should we be watching closely for compute?
CPU utilization spot the underused stuff. Maybe energy consumption per transaction, if you can measure it. Server utilization rates. Idle resource count and cost kill the zombies. It's really interesting how FinOps cost optimization and sustainability overlap so much here. They drive each other, and AI helping with this. That's a huge trend to watch. Okay, let's switch gears to storage. It's easy to forget how much energy storing all that data consumes.
Yeah, powering the drives, cooling everything. It adds up, especially with the sheer volume of data we generate. Inefficient storage isn't just wasteful, it drives up demand for hardware too.
Exactly. So optimizing storage isn't just about saving space. It's about reducing energy for data at rest, energy for data transfer, cutting carbon, and even reducing e-waste from old drives.
So how do we tackle storage efficiency?
First, lifecycle policies.
Hmm.
Automate moving data to cheaper, lower energy tiers. Infrequently accessed data. Move it to colder storage, like archival tiers. Base it on access patterns and retention rules. Second, use intelligent tiering where available, like S3 intelligent tiering. It watches access patterns and automatically moves objects between hot, warm, cold tiers. Takes the guesswork out, keeps data on the most efficient tier automatically.
Compression and deduplication must be big here too.
Absolutely essential. Apply data deduplication and compression. Get rid of redundant copies. Shrink file sizes before you store them. Less data stored means less energy used. And finally, be smart about ephemeral versus persistent storage. Do you really need to keep that temporary log file forever? Or that test environment data? Use ephemeral storage for transient stuff. It gets wiped automatically, minimizing long-term storage needs and energy.
Any examples of this paying off?
Well, AWS often talks about how S3 intelligent tiering saves customers millions, and that directly translates to energy savings, even if they don't always quantify the carbon aspect publicly. Azure Blob Storage Lifecycle Management lets you set rules for moving data between hot, cool archive tiers. Cloud providers also bake compression into services like Google Cloud CDN, dynamically compressing files.
What are the main tools for storage efficiency?
The different storage classes or tiers themselves, S3 Standard, Intelligent Tiering, Glacier, Azure Hot, Cool, Archive, Google Standard Nearline, etc. The lifecycle management features built into the storage services, compression and deduplication capabilities, either in the service or applied beforehand, and things like Kubernetes ephemeral volumes for temporary data.
What are the downsides or trade-offs to consider?
Pulling data back from cold storage like Glacier takes time, minutes, maybe hours, and often costs more per retrieval. So it's not for frequently needed data. Ephemeral storage means data is lost when the instance stops. You have to design carefully around that. It's not for persistent state. Setting up really granular lifecycle policies can get complex to manage. And compression, or dedupe, the CPU, which can add a bit of latency when you're writing or reading data.
Okay, moving on. Network and data transfer. Every byte zipping across the internet costs energy, right?
You got it. It's often overlooked, but yeah, network gear, cooling, it all uses power. Sending data long distances, especially across regions or out of the cloud, is particularly energy intensive. Inefficient network design equals wasted energy.
So how do we optimize network traffic for sustainability?
First principle, keep data close to compute. Minimize those long-haul cross-region or cross-data center transfers. Design your architecture so services that talk a lot are near each other. Second, localize data and services near your primary users. Reduces travel distance, latency, and energy. Third, consider edge computing. Push compute and data processing closer to users or data sources. Less data needs to travel back to the central cloud. Big energy saver for the right workloads.
And CDNs. Content delivery networks must play a role.
Huge role. Leverage CDNs like CloudFront, Azure CDN, Google Cloud CDN. They cache your content at edge locations near users. Data travels shorter distances. Origin servers handle fewer requests. Files often get compressed. It's a win-win-win for performance and energy. Also, optimize network paths and protocols. Use efficient protocols. For high-volume internal traffic, use private connections like Direct Connect or ExpressRoute. Inside a region, use VPT gateway endpoints to talk to services like S3 without hitting the public internet.
Any examples we can point to?
Think about how Netflix uses CDNs, like CloudFront, to stream video globally. Massively reduces load on their origins and energy use. S3 transfer acceleration uses the CDN network too for faster, implicitly greener uploads. Azure Edge Zones let you process data locally, cutting latency and transfer energy. And CDN providers themselves are getting greener using renewables. Good CDN usage can cut energy related to data delivery by like 40 to 80%.
What tools help architects here?
The CDNs themselves, CloudFront, Azure CDN, Google Cloud CDN, edge services like AWS Wavelength or Azure Edge Zones, private connectivity like Direct Connect, VPC endpoints.
And the trade-offs for network optimization.
Well, keeping data local might clash with multi-region disaster recovery plans that require data to be far away. Edge computing can be complex and costly to set up and manage. It also adds security challenges.
Let's shift focus a bit. How does the actual code we write and the way we build and test it impact sustainability?
It has a significant impact.
Yeah.
Inefficient code, bad algorithms, poor data structures, maybe using a less energy-efficient language leads to more CPU cycles, more memory churn, more network chatter. All that consumes energy.
So what can architects and developers do at the code level?
First, think about algorithmic efficiency. Sometimes a smarter algorithm can slash resource usage dramatically. Choose the right tool for the job. Second, consider the energy efficiency of programming languages. Generally, compiled languages like C, Rust, C++ tend to be more energy efficient than interpreted ones because they run closer to the metal. There's research showing Rust, for instance, can let you run the same workload on fewer servers.
We touched on event-driven and microservices before. They seem relevant here too.
Definitely. They're architectural patterns that enable efficiency. Event-driven means compute only happens when needed. Microservices, done well, allow scaling only the busy parts. Beyond that, simple things like in-application data compression before sending data over the network or writing to storage can make a difference. And a niche one, but for UIs on OLED screens, a true black-dark mode actually saves energy because those pixels are turned off.
Are there tangible results from focusing on code efficiency?
Absolutely. We talked about the e-commerce example using serverless. That's partly architecture, partly efficient use of resources triggered by code. And the language efficiency studies are pretty clear. Some languages just require less energy to execute the same logic.
What tools help with writing sustainable code?
Standard code profilers help you find performance bottlenecks, which often correlate with energy waste. Static analysis tools can catch inefficiencies. And increasingly, look at things like the Green Software Foundation's SCI specification, that's software carbon intensity. It's a way to actually measure and score the carbon efficiency of your software.
What are the challenges or trade-offs here?
Writing highly optimized code can take more time and effort, potentially slowing down development initially. Sometimes, the most efficient code might be harder to read or maintain. And measuring the exact energy impact of a specific piece of code within a complex cloud system, that's still pretty hard to do with granularity.
Okay, what about the process around the code? The CI/CD pipelines, testing environments, they must use a lot of compute too.
They really can. Think about all those builds, tests, temporary environments. If they're inefficient, run longer than needed, or sit idle, that's just wasted energy and resources. Sustainable CI/CD is about optimizing this whole life cycle.
So how do we make our builds greener?
You can implement green builds. Optimize the pipeline itself. Don't run redundant builds. Use caching effectively so you're not rebuilding unchanged components. Run tests in parallel to shorten the overall pipeline duration. Maybe even run your CI/CD tools in data centers powered by renewables. A big one is using ephemeral environments. Instead of long-lived dev or test environments, spin up temporary production-like replicas just for a specific task like testing a feature branch, and then tear them down automatically. No more idle environments burning energy 24/7.
Optimizing the tests themselves seems key too.
Hugely important. Optimize your testing strategy. Aim for maximum coverage with minimum compute. Run faster unit tests before slower integration tests. Automate what you can. Maybe run long test suites during off-peak hours when grid carbon intensity might be lower. Use the containers for test environments to pack them efficiently.
And streamlining the developer workflow.
Yes. Use infrastructure as code Terraform, CloudFormation to create consistent environments quickly and tear them down reliably. Automate cleanup. Make it easy for developers to spin up what they need and get rid of it when done.
Any tools or examples making this practical?
Some CI tools like Harness offer features like test intelligence to only run tests affected by a code change, cutting down execution time. The concept of ephemeral environments per pull request is becoming really common, speeds up review cycles, and saves resources.
What tools are fundamental for green CI/CD?
Your CI/CD platforms, Jenkins, GitLab, Azure DevOps, look for features like parallel execution and caching, IAC tools like Terraform, test automation frameworks, container tech like Docker and Kubernetes, And again, the SEI specification can help measure the impact.
What are the hurdles to implementing greener CI/CD?
Setting up things like sophisticated ephemeral environments or advanced pipeline optimizations can take significant upfront effort and tooling investment. Sometimes there's a tension between moving fast and optimizing perfectly. You might prioritize speed initially. Okay, underpinning all these specific actions, region choice, compute, storage, code, is the need for observability and measurement. You really can't manage what you can't see.
Right. You need data to know if you're actually making progress. So comprehensive monitoring is step one.
Absolutely. You need to implement comprehensive monitoring tools. Collect data not just on resource usage, CPU, memory, network, but try to correlate that with energy consumption and carbon emissions where possible. Tie it back to specific services and workloads. Visualize it. Then, define and track clear KPIs, key performance indicators specifically for sustainability. Things like energy per transaction, average CPU utilization, maybe PUE or WUE for the data centers you use. Make them smart specific, measurable, achievable, relevant, time-bound.
And this data enables things like carbon-aware scheduling, which we mentioned.
Exactly. Once you have good monitoring and ideally access to real-time grid carbon intensity data, you can implement carbon-aware scheduling. Shift those non-urgent batch jobs or data processing tasks to times when the electricity powering the data center is cleanest.
What about putting guardrails in place, governance?
Crucial. Establish a solid cloud governance framework that explicitly includes sustainability. Embed these considerations into your standard architectural reviews, your provisioning processes, your operational runbooks, make it part of the checklist. And finally, automate reporting and alerting. Set up dashboards showing your sustainability KPIs. Create alerts that trigger if you deviate significantly from your goals. This helps catch issues early.
What tools are indispensable for observability and measurement in this context?
The cloud provider's own tools are the starting point. AWS Customer Carbon Footprint Tool, CCFT, Azure Sustainability Calculator, Google Cloud Carbon Footprint, they give you direct emissions estimates. Then you need general monitoring tools, Datadog, Grafana, New Relic, to track the underlying resource metrics that feed into your KPIs. Open source tools like Cloud Carbon Footprint can also provide cross-cloud visibility.
Are there challenges with monitoring for sustainability?
Yes. Getting truly granular data and accurately attributing energy use or carbon emissions to a specific microservice or workload can still be complex. It often relies heavily on good tagging practices. There's also the cost of monitoring tools and data storage. And while things are improving, standardized reporting across all providers and down to the workload level is still evolving.
What metrics should architects really keep their eye on?
Energy per key business transaction, if possible. CPU utilization aiming for optimal, not idle, PUE and WUE of the regions you use. The software carbon intensity, SEI score for your applications. And tracking your overall Scope 3 carbon emissions from cloud usage. Now, all these technical strategies are great, but making sustainability stick, that requires more than just tools and techniques. It really needs a shift in the organizational culture.
So architects need to be influencers, not just implementers. They need to change minds.
Exactly. Architects are often technical leaders. They need to champion sustainable design, educate their teams, advocate for including sustainability goals in product roadmaps alongside features and performance, show how it benefits the business cost savings, brand image. A key mechanism is to embed sustainability in architectural reviews. Make it a standard agenda item, have a checklist, ask the tough questions about the environmental impact of design choices.
And linking it to business goals, like OKRs.
Yes, that formalizes it. Integrate sustainability into OKR's objectives and key results. Work with leadership. Make reducing the cloud carbon footprint an actual, measurable goal for teams, right alongside revenue or uptime targets. For instance, reduce compute emissions by 15% this quarter.
What about influencing purchasing decisions, green procurement?
That's another angle. Advocate for green procurement policies. When choosing vendors, software, even hardware where relevant, factor in their environmental credentials. Work with finance and procurement teams to make ESG part of the evaluation criteria. And overarching all this is fostering a culture of green computing. Training, workshops, sharing best practices, maybe even friendly competitions, or recognition for sustainable solutions. Make it part of how everyone thinks about building software.
Are there examples of companies really embedding this culturally?
You see companies like SAP building sustainability, reporting right into their core product offerings, which naturally influences how their customers architect solutions. Microsoft's Cloud Adoption Framework explicitly lists sustainability as a driver and suggests relevant OKRs. Government procurement guidelines, like the USGSA's Green Procurement Compilation, also offer models for how organizations can approach this systematically.
What tools help facilitate this cultural shift?
Things like having well-defined architectural review checklists that include sustainability, using standard OKR management tools to track progress, developing internal green procurement guidelines, using internal wikis, forums, or training platforms to share knowledge and build community.
What are the main challenges in changing the culture?
It takes time and effort, training, change management. There can be resistance. People are busy, focused on existing priorities. Architects need to clearly articulate the why and the benefits. Sustainability often competes with other urgent business needs, so making the case for its long-term value is critical. And it requires real cross-functional collaboration, engineering, finance, product, procurement, which can be hard to coordinate. So we've talked about a lot of optimization strategies, but let's be real. Cloud architecture is rarely about optimizing just one thing. Sustainability often involves trade-offs with cost, performance, latency, availability.
Right, like the example of high availability often needing more resources, which bumps up the environmental footprint. How do architects navigate these conflicts?
Exactly. Or choosing that ultra-low latency region might mean accepting a higher carbon grid. Managing these trade-offs consciously is maybe the most critical skill. It's about making informed choices that balance business needs with environmental responsibility.
How do we approach this systematically?
First, use decision-making frameworks that force you to consider all the angles. The AWS well-architected framework itself is designed for this, making you balance sustainability against the other pillars, like cost, reliability, performance. Second, prioritize based on the workload's needs. Is it a mission-critical, user-facing system where latency is king? Okay, maybe sustainability takes a slight backseat on some decisions. Is it a back-office batch job? Then you likely have much more flexibility to prioritize the greenest option, even if it's slightly slower or runs in a farther region.
Quantifying the trade-off sounds important, putting numbers on it.
Absolutely. Quantify the impacts as best you can. What's the estimated carbon saving of using this region versus that one? What's the potential latency penalty? What's the cost difference? Bringing data to the discussion helps move beyond gut feelings. This is where FinOps practices, extended to include sustainability, are incredibly valuable. You might even explore concepts like approximate computing for non-critical tasks. Does the result need to be 100% precise, or is 99.9% good enough if it saves significant energy? Or accepting slightly slower response times sometimes.
And designing for failure modes smartly.
Yes, designed for graceful degradation or selective activation. Instead of having a fully redundant active setup running constantly, maybe you activate the failover environment only when disaster strikes. Or allow non-essential features to degrade slightly during peak load or when grid carbon intensity is very high. Saves energy consumed by idle redundancy.
Any examples of these trade-offs in action?
The well-architected framework itself is full of them. Recommending tiered storage, like moving data to Glacier, is a classic trade-off. Lower cost and energy use, but higher retrieval latency. Balancing resilience patterns, maybe choosing active-passive over active-active if the availability requirements allow it, saving resources. FinOps teams constantly make these calls, balancing greener options against potentially cheaper, less green ones.
What tools or frameworks help manage these decisions?
FinOps frameworks are key, especially as they increasingly incorporate sustainability metrics. The well-architected framework process itself, forcing multi-pillar thinking, and the cost and carbon footprint tools, CCFT, etc., provide the raw data needed to inform the trade-off analysis.
What are the biggest challenges in managing these trade-offs?
Just acknowledging the conflicts exist and tackling them head-on, rather than optimizing in silos. Getting accurate data to quantify the impacts can be tough. Getting buy-in from different stakeholders who might prioritize cost over latency over sustainability, or vice versa. And realizing that the right balance isn't static. It changes as technology evolves, prices change, and regulations shift. It needs continuous review. Finally, let's peek into the future. Cloud sustainability isn't standing still. It's evolving fast regulations, market pressure, new tech. It's solidifying its place as a core architectural concern.
So what should architects be doing to stay ahead of the curve?
Keep learning. Stay informed on emerging standards, like the Green Software Foundation's SCI spec we mentioned. It's gaining traction for measuring software carbon intensity. Monitor the cloud provider roadmaps. They all have ambitious goals like net zero, 100% renewables, water positivity. Know what they're committing to. And engage with communities like the Green Software Foundation. That's where a lot of the cutting-edge thinking happens.
And I imagine AI will continue to play a bigger part.
No doubt. Explore AI-driven sustainability optimizations, We're already seeing AI used in data center cooling and power management. Expect more tools that use AML to predict workloads, optimize resource allocation automatically, maybe even dynamically shift workloads based on carbon intensity green-offs, essentially. Also, start thinking about circular economy principles. How can we design systems that maximize hardware life, allow for reuse, minimize e-waste? It's moving beyond just operational efficiency.
Are these future trends already starting to show up?
Definitely. The Green Software Foundation is active, the SEI spec exists, the cloud providers are making big public commitments and showing progress like AWS hitting 100% renewable matching in 2023. AI is already optimizing data centers behind the scenes.
What specific tools or trends should we watch closely?
The SEI specification watch for its adoption and tooling around it. Expect more granular real-time carbon data APIs from cloud providers, more sophisticated carbon-aware scheduling built into platforms, AML tools specifically for green ops, and continued growth in edge computing, which inherently helps with data transfer energy.
And the challenges looking forward.
Adopting new tools and standards takes investment time, money, training. Integrating these into complex legacy systems won't be easy. Getting standardized, comparable carbon data across all providers is still a work in progress. And balancing the energy demands of new tech, like large AI models, with sustainability goals is a key challenge.
Wow. Okay. We've covered a huge amount of ground today. We really took a deep dive into how software and cloud architects are central to building a sustainable cloud. From picking regions, optimizing compute and storage, to coding practices, and even changing company culture, every choice matters.
Absolutely. And the key takeaway is that the AWS well-architected framework's sustainability pillar. It's not optional, it's not an add-on, it's fundamental to building truly well-architected systems now. The cloud offers amazing potential for efficiency, but realizing that potential fully. That depends on your continuous conscious efforts to optimize in the cloud.
Yeah, and what's really striking is that this isn't just about, doing less harm. It's actually unlocking innovation, finding new efficiencies, building more resilient businesses. It feels like a genuine win-win. And you, the architect listening, you're right in the middle of making that happen. So what stands out to you from our discussion today? What's one step you might take this week to embed sustainability a bit deeper into your work?
It's been great exploring this. Thanks for joining us.
And definitely stay tuned for more deep dives. Make sure you subscribe to The Joy of Architecture.